So where we left off last time, we were able to load an image in the game, which looks like this. But the image is way too big, and there's this white space around the outside, and the collision detection is probably all broken. So let's fix all those things. Let's start by editing the image itself. So here's my image inside Assets. If you right-click, you can say Open in Explorer, or in Macs, I think it says Reveal in Finder. But the idea is we want to be able to go to the place in the file system where the file actually lives. And then I want to edit it with an image editor. I use paint.net, which is a nice free one that I think is cross-platform. So I'm going to use paint.net here, but you can use whatever your favorite image editor is. And the first thing I want to do is just crop all the white space around the outside. So I'm going to try and line this up. So I'm off by a pixel, it would seem, but that's okay. I'm going to keep the tail of the balloon, but we'll say image crop to selection, and then I'm just going to resave it as that same image. If I wanted to, I could resize this image right now, but I want to show you how to do that inside the game itself. Here, let's take a look at the balloon. Okay, so now you can, I don't know if you can see, but the white space as compared to the gray, like we've clearly cropped the image. So let's go back to where we're loading the image here in the balloon constructor. So one thing that's a little bit strange is the balloon constructor takes a width and a height, which is presumably supposed to describe the size of the balloon, but then we go ahead and we create the balloon image in just whatever size it already is. So let's do this. Oh, I thought of a reason why these can't be static. Well, let's do this. So here was my thinking. My thinking was, oh, if we have balloons of different sizes, now we can't share this same P image across all of the instances because it needs to be displayed at different sizes. And the second thought I had was, well, maybe let's just resize it whenever we draw it. I don't know if that's going to be slower or not, but let's try it. So right before we draw it, I'll say balloon image dot resize as a built-in method of P images, and so I can resize it to the width and the height. Oh, my attributes are called width and height. So we'll resize it to the width and the height, but they need to be ints that my attribute says. Okay, fair enough. So right away, let's run it, and we should see a change. Because I don't think the balloon image was actually the exact size that I was trying to create my balloons at. Ah, yes. So now we have balloons. I can see that my width and height have actually ended up making this a little bit distorted when I resize it. So that's something we can think about in a minute, but let's not change that yet. Let's look at the collision detection. So right now, the way the bullets detect whether or not they're overlapping the balloons is it with this single line. So this is inside the bullet class, and the bullet is asking, am I hitting this particular balloon? And the way we do it is we calculate the distance between the center of the bullet, so xy here describes the center of the bullet, and the center of the balloon. Here xy is supposed to describe the center of the balloon. And we see if that distance between the centers is smaller than the balloon radius. Although that's a little bit wrong because it should really be the balloon radius plus the bullet radius. Maybe the bullet radius is so small we don't really care about it. Let's add it in though. Okay. So that makes sense. Here's the problem. The problem is before inside the balloon class, x and y describe the center of the balloon. The reason they describe the center of the balloon is because the way that we used to draw it was we would say, let's draw an ellipse that's centered at xy. So it's like we made the choice for what xy would represent when we decided to draw a shape relative to that point. And the way that we drew it relative was we drew it centered at that point. The problem is, now we're not drawing an ellipse anymore. Now we're drawing an image. And the way the image command works, it's going to draw the image using these coordinates as the upper left-hand corner. So what used to be the distance between the center of the bullet and the center of the balloon is now the distance between the center of the bullet and the upper left-hand corner of the balloon. And that doesn't really make sense as a way of calculating whether or not two circles are overlapping. So here's my solution. Let's replace get x and get y with get center x and get center y, because that's what we really want to get. We want to know where is the center of the balloon. So if I can make methods that do this, I will know that my old approach to collision detection is still working. So let's leave this unimplemented for the moment. Let's get this going. Whoops. Okay. So how are we going to figure out the center of the balloon based on the upper left-hand corner? It might seem tempting to do this. I could say, I know what the left-hand side is. So x is the left-hand side of the image. So maybe I should just take x and add half the width. For the center x, I think that that's going to work. Let's take a look at the image and think about it. So if the left-hand side is x and this is the width, yeah, the center of the balloon should be x plus the width. So here we are in the middle. But for the balloon height, I don't want the center of the balloon to be here down where the string meets the balloon. I want it to be in the center of the balloon part, because I actually don't want to include the tail here as part of the collision detection. I just want to treat this circle as part of the collision detection. So we're going to have to think about how to deal with that. So I think this works fine for get center x. For get center y, I think we want y plus and then something else. If we want to treat this like a circle, then I think we could really say width divided by 2, because that's going to place the y coordinate the same distance down as the x coordinate is over. So it's really going to represent a circle. Because this looks like it's not on purpose, though, because it would be very easy to mix up width and height here, I'm going to add a comment saying that this is on purpose to the image. Okay. Sometimes it's helpful to put a comment that you did something on purpose, not by accident. All right, so I think I've probably just fixed the collision detection by keeping the original idea, but just writing new methods that give me the coordinate that I wish that I had when the meaning of my xy changed, when I stopped drawing ellipses and I started drawing images instead. Okay, let's take a look. I think we probably want to do one last thing, which I'll put in another video. Let's see what it looks like, though. Okay, so it's a little bit hard to tell if the collision detection is perfectly working, but I did see a bullet pass through the string section without damaging anything. So I think the last thing I want is, I wish it had a transparent background. So let's do that in a last video.